Sounds great. Hi, I'm Natalie. I'm super excited to talk to you. I would be even more excited if Snowmageddon didn't happen and I could be there in person. But I'm here to talk about some of the misadventures I've had in federal cryptography. Decided to call it There I FIPS'd It, because that's kind of the attitude I've seen sometimes. I do application security, supply chain threat modeling, and software factory stuff for the public sector. And there's something about cryptography that really excites people, but also kind of scares folks too with is this right? And I don't know. Slides are here, so that just put the QR code up there. All opinions and snark are mine and not past, present, or future employers. But let's talk a little bit about why this is a problem. There are new standards, or new-ish. Public sector, the definition of new can kind of be a little wishy-washy sometimes. But there are new standards in FedRAMP, so there's a new revision to NIST 853. There's also new ways that we're approaching these controls in FedRAMP 20X and in CMMC 2.0. There's also a new revision of FIPS 140. But on a bigger scale, there are new companies entering the federal space. There's new authorizing officials evaluating that risk. There are new tools making shortcuts easier to take and harder to spot. And the rules necessarily weren't thinking about some of the more modern architectures that we use these days. But to be clear, Jeff here is not the problem. But let's take a step back real fast. What do we mean by FIPS? A little bit of government soup, alphabet soup, anyway, before we go on. NIST maintains all the standards, from everything from what's in peanut butter and how much a kilogram really is, to digital cryptography and a ton more. Some of the standards they write are FIPS. There are lots and lots of these standards. If you want to store paper records in a banker's box, there's actually a FIPS standard for that. However, these are the ones that we really kind of need to know. 140 is for encryption, and the kind of sister to that is 890B for randomness or entropy. And your authorizing official is kind of the other one we really want to know, and that is the super cool person that actually accepts risk on a system. They're the person that signs off and says, yes, this is FedRAMP authorized, or this is authorized to operate. And this person may not be a cryptographer. Actually, they're likely not going to be a cryptographer. They might not be a developer, and they might be incredibly technically deep in something that is completely not related to your application. And that's okay. The idea of risk and how we communicate it is still the most important. And there's this one cryptography diagram that literally everyone has seen before, where Alice and Bob need to communicate, and they need to communicate without anyone else overhearing, or more importantly, being able to intercept that. And that complete gibberish in between, that's called ciphertext. But actually making this happen is really, really difficult. Alice and Bob have to agree on how to exchange keys and then do it. They have to support the same algorithm, both of them, in order to translate between that ciphertext and plain text. And then they have to have enough randomness to do this securely. And the methods used change on if this needs to be symmetric or synchronous or not. And most importantly, both sides have to do all of this correctly. So, enter FIPS. The first revision of FIPS 140 was published in 1994, and it was withdrawn in 2002. Second revision, and now we're on our third revision right now. And the spirit of the law, kind of not really thinking about the particulars of which algorithms or which ciphers are appropriate, is that this gives you a secure paved path to do this tricky thing well. So you use a module that's been peer reviewed and validated independently to work as expected. Or this lovely red box here is exactly what that module is. And before anyone gets crazy, oh wow, I just described using a library. Yeah, remember 1994, this was before software development, kind of GitHub, open source existed. We didn't really have this concept of easily shareable libraries. You bought one. And it sounds super easy, right? You get a module, you wire it up, easy peasy. But let's look and see some of the ways I've seen this done poorly over the past 10 years. The first is, where do you draw the line? The thing is, Alice and Bob aren't writing letters to each other where there's no one control point to rule them all. It's a little bit more nuanced. And by a little bit, I mean it's actually thousands of instances of microservices or dozens of different cloud regions, all handling communication between Alice and Bob. So it's a lot more mesh or mushy, honestly, than the nice, easy textbook diagrams. And this net is only as strong as the weakest link. So back in my day, like when I was getting started, it was super common to put a FIPS mode VPN in front and then throw your whole vSphere cluster on FIPS enabled storage. That gets you encryption in transit, VPN, obviously, and encryption at rest. It's on a validated storage. And when we pause to think about the threat model here, you're protected from someone stealing hard drives from your data center. And I'm going to say maybe protected between the endpoint and the edge VPN. I'm not a big VPN fan. But you have unencrypted communication between the database, the file storage, your in-memory cache, like whatever bits and pieces go into your application. However, we did check all of the it's in FIPS mode boxes, and this doesn't really fly anymore. It's still common to see exceptions for all sorts of reasons. Budget, risk acceptance, mitigation, the application genuinely can't support this. But the least acceptable reason, the one that you can't really mitigate, is you don't actually know how data moves in your system or have it written down. But is it okay? Ask your assessor. The next one is this lovely temptation for compliant but not validated. The temptation to write something to spec is really, really real. FIPS 140-3 is 11 pages of guidance. That's it. All cryptography in 11 pages, which is to say, it's actually 11 pages of referencing other documents. So there's a couple hundred pages of ISO docs that it references. Then there are annexes and special publications that are referenced. And those also reference additional documents, like RFCs, et cetera. And then there's another couple hundred pages of implementation guidance. It is a very, very specific specification, like that's what you want. The thing is, just because you can doesn't mean you should. There's all of the time of actually trying to write something to spec. Then there's all of the time of getting it validated and maintaining that validation, maintaining that software over time, versus licensed modules being in the 5 to 6 figures a year for most use cases. Again, just because you can doesn't always mean you should. But let's just say, how do you start finding it? My favorite, the easiest, most definitive way is code review. So you can pretty easily go like, hey, this is the application, like what are the parts that are connecting, where do we need to be encrypting data? You can't always get the source code though. And poking at it can be pretty good. And most of the time, if you're DIYing it, I typically find that you've only implemented a few algorithms. DIY, not compliant, it's pretty easy. Haven't disabled the non-approved algorithms. Again, we'll talk about that in just a sec. Or it's actually just plain old regular upstream OpenSSL or libsodium or whatever library it is you're using. And that's fine. It's actually probably the least bad of all of these options. It's probably pretty good. And it's also not validated. My little enumeration favorite here is testssl.sh. It does any TLS service. It's open source software. Super duper easy to parse output, and then you're going to compare the list of ciphers offered to the list of ciphers that are allowed. And it checks a ton more other than just that, but for the sake of this is kind of what we really look at. My favorite poem proof, So when I need to screenshot that something is or isn't working, is OpenSSL. And you can just echo a get command into it, specify the host, the port, the cipher, and you're going to just pull a list of ciphers and find an expected failure. Like for FIPS, RC4 and D5 should fail. Anything based on cha-cha 20 should fail, or any of the cha-cha curves. Curve 25519 key exchange, not allowed. And AES 256 should succeed. And of course, it's already an in-map script. It's SSL enumerate ciphers. But the problem is we're in this business of match offered ciphers to a list somewhere that's hopefully right. And it's not all that great. And going back to that big mesh diagram, well, just because we can see one part of this network from our enumeration doesn't mean that we can see the whole system. So there is a better way. You can ask for, and you should be able to receive easily, the CMVP certificate. So going back to validated, the cryptographic module validation program has a lovely website. It's right there. You can click it. You should be able to search. You should ask your vendor, like, hey, what CMVP certificates do you have? You should look at those. You should state it's validated, it's not expired, it has a list of validated algorithms associated with it. And then you should check the caveats of that, because you might need something in there that's you need to understand. Like, it's only FIPS validated when it's operated in FIPS mode. That tells you you need to tell it, hey, I need you to operate in FIPS mode. Or that there's no assurance of minimum key strength. So if you have a separate key that it needs to load, that module can't understand what you're putting into it or validate the strength of that. Super easy website, not terribly complicated. It is beautifully easy to use. And if you don't have one, you're not validated at all. Note, I didn't say insecure, just that you're not validated. And there are some rules about non-approved algorithms that really trip people up. And that is that non-approved algorithms can be used for non-security purposes. And the trick here, the weird part that trips people up, is that this means that a module can allow use of a non-approved algorithm, but you have to say it's for a non-security reason. And most modules, to avoid all of this audit paperwork, will just not include those algorithms. And that's okay too. Like, you can't argue about using a thing wrong if that thing doesn't exist. Both of these objects are good. But this is the common reason that FIPS mode breaks something in your application as you're going from that journey of non-FIPS to FIPS. Some really, really common exceptions. S3 uses MD5 as a fast hashing algorithm. So if you want to upload a file, it's going to say, hey, this is the hash. Check the hash. It's just a basic integrity check. Git, the version control system, Git, uses SHA-1. SHA-1 is not allowed. Ask your authorizing official or your assessor to guidance. You may be asked to prove it, and that's okay. So when something breaks, a common and unfortunate problem here is just disabling validation altogether. It's 2026, and it's still sadly common. And it doesn't matter if anything is encrypted or not if you're trusting everyone. So searching for one very large central Git repo for only public things, you can find a lot of things. A lot of icky, uncomfortable things. And it is true that skipping certificate validation is like step 0 when debugging anything. You just have to remember to turn it back on. My favorite way to look through this is to do some dorking in like a GitLab or GitHub repo. It's also really, really common to find this wherever you see a cloud access security broker or zero trust proxy, anything that's going to SSL intercept and inspect, you'll find this. Static analysis tools find this, basically any of them. But sometimes all you need is grep. So you can rip grep through a code base, pretty straightforward, and find most of these strings. This is commented out, that's kind of boring. Based on context, this guy looked like it was in test. Probably not a big deal. But everything else, it just makes me really, really uncomfortable. And the thing I really dislike about this is that no encryption won't pretend to exist. So this will pretend to exist. It'll say, yes, we're encrypted, HTTPS is on, or whatever protocol you're working on. He's just trusting everyone. And is it okay? Ask your assessor, but probably not. In my experience, this has always been a failure. But there are always really, really fun, creative ways to mangle it too. Because many compliance checks are super simple to fool. Some of the things that I found in the field, editing OpenSSL config file to only offer allowed ciphers, forcing files to falsify FIPS mode, using a process profiling tool to omit certain files means maybe you don't get everything you need for FIPS validated cryptography to work. FIPS mode checkboxes that do nothing but look beautiful in a screenshot. And renaming the module provider to have FIPS in the name, again, not cool. And fortunately, I actually don't find these that often. However, every now and then you can find something that's really kind of silly. And I promise you, whatever software costs, it's not as much as getting kicked off a contract, being held liable, all that good stuff, or something like this. So this is a Fedora host and a Rocky Linux containers, which is a rebuild of Red Hat. There's no FIPS here. There's no Red Hat validated FIPS providers, but if you mount a file that just contains the number 1 at proxys crypto FIPS enabled, inside the container will think it has a OpenSSL FIPS provider here. Not a good look. More importantly, you're going to multiply this complexity across each tool chain and each language in your environment. So Java isn't weird. Java JVM, though, doesn't use the host cryptography all the time. So always just look at the cryptography architecture. Every time I Java, I have to relearn how to Java. Go has a million options that are validated, and they all have varying degrees of support. Some of them are not, some of them are commercially supported, like just figure out what you're going to use there. Rust is kind of cool. It's in order to preserve portability, the standard library in Rust doesn't implement cryptography at all. So in order to do this, you also have to have a cryptographic implementation to put in your standard library in order to have the module be there. And containers are kind of the fun one. That's where I've spent a decent chunk of my career. And a container is just a funny way to package a Linux process. So you need to either have that validated source of entropy in the host and pass that in, or you can bundle a validated source of entropy in the container for it. You also have to have that validated module available for that container to use and not just on the host. And the only tricky part about validation, if you start poking around, is you typically won't have OpenSSL or a shell or other tools available in the image. So you'll need to use either the API of the library and use or sidecar into that container to verify it. And so on and so on and so on when you start looking at however many tools and languages and frameworks that your application has. But there's a lot of cause for, I'm going to call it hope. Audits are getting better. Auditors are getting better. This is not as scary as it used to be. You used to have to do a lot more work on the engineering side to implement FIPS. You can now just say, hey, AWS or Azure, I want to use a FIPS validated storage with FIPS validated everything. And that doesn't completely alleviate the need for you to understand, of course, your application and your application's workflow and all the parts and pieces of your application, but it does give you a much more service-driven approach to not owning as much of that infrastructure. Your area of responsibility and expertise is smaller when you pay someone else to do it. Or all of this to say, security and compliance aren't tightly coupled. There are fantastic secure open source cryptography libraries that aren't validated. And it's probably way better for you to use those than it is to you do something poorly. Always check your language and your framework for best options. Use the validated libraries as needed. It's probably easier to just pay for it. Pay a SaaS to do it, pay something to do it. Read the docs. Don't ask artificial intelligence. I vibe coded an RSA implementation because RSA is like a really simple system to understand. It's just modular exponentiation. And I said, hey, can you make this FIPS 140-2 compliant? Thinking that it's the older system, like it'll have more training data. Thinking. Yeah, line 11. That makes me a little uncomfortable. Yeah, for those of you who can't see it and I can't see the room, a prime exponent on line 11 of 1 doesn't encrypt anything. 3 and 17 are probably also very bad as well. Yeah, not a good look. Most importantly, this is hard. Ask for a second opinion, but make sure that you budget for it in people, in time, and in money. There's no easy now. This is your life. Godspeed. Cryptography is hard. Shipping code's hard. Knowing your data flows. Documenting it. Determining what is or isn't relevant to security. All of these things, these are all hard. Code review is also hard. But most importantly, as someone who's been both practicing and on the vendor side, always approach your vendors with trust but verify. You can and should ask. And the answer to life, the universe, and everything is always ask your authorizing official. And with that, I think I have a few minutes for questions. I'm not sure.
Hey, Natalie. First of all, we've unmuted now, so I can give you this nice big round of applause for this really awesome and interesting presentation. Yay! No idea.